Welcome to Chapter 10. Chapter 10 is on probability, and in Section 10.1, we will be discussing the fundamental counting principle as well as different forms of permutations. In 10.1 and 10.2, our main goal is to count the number of possible ways that we can select items or objects or people. And we're going to learn multiple ways to do that today. For example, we are in the market for snowboards, and we go to some sporting goods store, and they tell us that there are 3 different types of snowboards, and there are 2 different types of boots. How many total possible sets of choices do we have? Now, you have probably seen questions like this in previous courses, and what your teacher probably advised you to do was to make a tree diagram. It says we have 3 different choices for snowboards. We could have the mountain snowboard, we could have the freestyle snowboard, or we could have the carving snowboard. And then from each of those 3 choices, we could choose one of the 2 different types of boots. We could choose a soft boot or a hybrid boot. We could choose freestyle and a soft or a hybrid. Then we could choose the carving and a soft or a hybrid. So then we would count how many total branches that we have at the end, right? We have mountain and soft, and then we have mountain and hard, freestyle and soft, freestyle and hard, carving and soft, carving and hard. That was 6 total choices that we just had there. And so we would say, hey, there are 6 different choices that we have, right? Now, a tree diagram obviously isn't going to be the best method for us to calculate the number of choices, especially as we get into really complicated problems. What this is an example of is something called the fundamental counting principle. And this is going to show up in multiple different ways as we proceed throughout the chapter. What the fundamental counting principle says is if we have some event that can occur in m ways, right? And then we have another event that can occur in n ways. In the previous example, we had an event that could occur in 2 ways, or 3 ways, right? We had the mountain, freestyle, and carving snowboards. And then our next event could occur in 2 different ways, either the soft or the hybrid boot. And then in order to calculate the number of ways, we simply multiply those things together, and that's how we come up with that number 6. 6 options. It is worth noting that the fundamental counting principle can be extended into more than just 2 different individual events. If I also said, hey, there are 5 different color choices, then you would say, okay, there are 3 different options for the first event, 2 different options for the second event, 5 different options for the third event. In total, we would have 30 different options. On your guys' upcoming quizzes and tests, and then these types of problems in general, license plates are going to be really common examples for this. So I have no idea if this is true, but it says Texas license plates go 1 letter, 2 digits, 3 letters. Question A says how many different possible license plates could be created if we say that the options can be repeated. And in order to answer this question, we would use the fundamental counting principle. And I'm going to draw like a fake little license plate here. You don't have to do this, obviously. It says that the first location is 1 letter. You guys know that there are 26 different options for letters, right? So our first event can occur in 26 different ways. The fundamental counting principle says we would then multiply that by the number of ways in which the second event can occur. And the second event is going to be a digit, it says. And if we count the digits 0 through 9, that is a total of 10 different options, right? And then the third event is also a digit. And then we have 3 more letters, times 26, times 26, times 26. We type that into our calculator and get the answer. That would tell us the number of possible license plates that would meet this criteria up at the top. And what we would come up with would be 4, 5, 6, 9, 7, 6, 0, 0. So 45 million or so license plates could be created using that criteria given at the top. Question B is a little bit different. It says that how many, given the same criteria, can be created if we cannot repeat either letters or digits. So if we are to go about answering this question, our first event can still occur in 26 different ways because our first event is a letter. The second event is a digit and still can occur in 10 different ways. But our third event can only occur in 9 different ways because whatever digit was chosen here cannot be repeated. And so let's say that this digit was 4. Okay, now that option has been removed. Now there are only 9 different options for that second digit. The same thing is going to be true for all the letters. Our fourth option is a letter, and whatever was chosen in the first location cannot be repeated, so I only have 25 different choices left, and then 24, and then 23. So we type that into our calculator, 26 times 10 times 9 times 25 times 24 times 23, and we would come up with 32,292,000. And so because we cannot repeat the letters, we have some options removed, and that lost quite a few, 13 million or so possible license plates. So 10.1 is not only about the fundamental counting principle, we also are going to look at 2 different ways to count the number of ways that some events can happen. The first way that we're going to look at is something called factorial. The premise behind factorial is you have n events, or n objects, and you are going to figure out how many ways that you can position them, essentially. So we have n objects, and we want to select all n of them. And we're interested in how many ways that we can order that selection. The notation that we are going to use to exemplify factorial is going to be an exclamation point. So let's say I have 5 objects, and I want to arrange them in some, and I want to select all 5 of them. I want to arrange all 5 of them. I want to know how many ways I can do that. The notation we would use would be 5 factorial. And the way that we would calculate that, right here, 5 factorial is equal to, take that number, 5 times n minus 1. So n is 5, so I would take 1 away, 5 times 4, and then take 2 away from 5, that would be 3. And then remember the dot, dot, dot just means continue in this fashion until you get to the number 1. You have 5 times 4 times 3, then you would take away 3 from 5, and you would have 2, and then you would take away 4, and you would have 1, and 1 is our stopping point, right? You're always going to end at 1. So you would have 5 times 4 times 3 times 2 times 1, that answer is 120. And so there would be 120 different ways that I could arrange them. This is like saying if I had 5 of you students that were going to sit in the front row, and I wanted to know how many ways that I could arrange all 5 of you. So then this would be a factorial problem. There's 5 students. I'm selecting all 5 to arrange, and so I do factorial. The way to do this on our calculator, you just type in 5, and then factorial, that exclamation point, is found under PRB for probability. That's where we're going to be today and throughout the chapter 10. You go 5, PRB, and then the 4th one down is factorial. You'll see that you get 120. So we're clear that factorial then is always going to be, take that digit, let's say you had 10 factorial, that would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. You always take whatever number it is, and multiply it by every number less than it until you get to 1. Permutations is really similar, only we are not selecting all n objects, typically when we're doing permutations. Let's say, going back to that example of having 5 students and I want to arrange all 5 of them, that would be factorial. But let's say I only wanted to arrange 3 of them. Okay? I have 5 of you to place, but I only have 3 desks in the front row. So I want to say, how many ways are there to arrange 3 of the 5 students? That would become a permutation problem. And the notation for permutations would be take the larger number, how many objects you are selecting from, which is 5, capital P, and then the number of objects that you are selecting, which in this case would be 3. And then you can see the formula here. So it would be 5 factorial, right? Because 5 is n. So 5 factorial divided by 5 minus 3 factorial, which ends up being 5 factorial over 2 factorial. We already know what 5 factorial is. We did it up here. It's 120. And we already know what, we know what 2 factorial is. 2 factorial just means 2 times 1, which is obviously 2. And so we would end up with 60 different ways that I could select or arrange 3 of 5 students. Now there is a way for you to type this into your calculator. This one right here, 5p3. What you do is you first type in the n value, which is in this case 5, and then you will go back to that math PRB, and you will see NPR. NCR, that's for combinations, that's going to be in section 10.2. So it would be 5 NPR 3, and then you just push enter, and you would come up with the number 60. Let's say that Mr. Nyquist is in charge of a mathlete race, where the students run a mile as fast as they can and they solve a math problem. How many ways can his class of 10 finish? So you guys are going to have to kind of think about this in say, hey, is this the fundamental counting principle? Is this permutations? Is this factorial? We're going to look at other different options as well throughout the chapter, and you guys are going to have to select the right one. Now, in this example, there are n students to choose from, and I want to know how many ways all 10 of them can finish, right? I'm not saying how many ways can my top 3 finish, I'm saying how many ways can all 10 finish. That tells us that it is factorial, and so it would just be whatever 10 factorial is. We can go to our calculators, remember, and type in 10 math PRB factorial, and we would get this number, 3628800. Just so you guys are aware, factorial does increase incredibly quickly. We noticed 5 factorial was only 120. 10 factorial is over 3 million. It is worth noting, I'm going to go back to that last example. It is worth noting that let's say that you did permutations. You say, hey, there are 10 students, and I want to select all 10 of them. That'd be 10p10. You would also get the same answer. So you could use either the permutations formula, or you could do factorial for that problem. This next one is not the case. Okay? This next example says something similar, but I only am interested in the top 3 finishers, first, second, and third place. Okay, 4 through 10, I don't care what order they finish in. So this would be a permutations problem. There are a total of 10 students still, and I'm interested in how many ways that the top 3 could finish. So this would be 10p3. We go to our calculators, we type that in, 10, start with the 10, the n value, and then go math PRB, NPR 3, and we would come up with 720. Far less ways, if I'm only interested in the top 3, there are far less ways that that event can happen. I do have one problem left, but I'm going to kick that to the next video. I'm running out of time. I do want to talk about this permutations formula really quickly, because in our next lesson, and I kind of referenced this earlier, there's something else called combinations. So permutations is when the order is important. And what I mean by that is the order in which those objects that are being selected matters. So this problem here is a permutation problem because first place gets 1,000, second place gets 500, and third place gets 100. The order in which those objects are selected matters, and that's what makes it a permutation problem. Thanks, guys.